All right, operations with imaginary numbers. So, adding, subtracting, multiplying. How do we work with these imaginary numbers? You're going to be happy to find out that you work with them very similarly to how you would work with regular variables. So, for example, in this particular box, let's do adding and subtracting. How would we handle adding and subtracting variables or numbers that have imaginary numbers in them? So, example, 8 plus 3i minus 2 plus 4i. Maybe that's what we're doing today, okay? And so you're going to think combine like terms. Just like you would if those were variables in there. You're going to combine like terms. I'm going to go 8 and negative 2. So 8 minus 2 is 6. And then 3i plus 4i. That's just like if I said 3x plus 4x, right? You would tell me that it's 7x. So in your head, 3i plus 4i just equals 7i. And you don't have to do anything with the I. It's just as though it's a variable. Okay? So that would be your answer there. All right? How about this example? Maybe I do 5 plus 7i times negative 2 times I minus 3. Maybe that's what it says. So here I have to do some distributing. I have a negative in the middle of my parentheses. Anytime there's a negative in the middle of the parentheses, you need to distribute it to the inside of the second parenthesis. So 5 plus 7i, negative 2 times I is negative 2i, and negative 2 times negative 3 is positive 6. Again, combine like terms. 5 plus 6 is 11, and 7 minus 2i is 5i. Done. So adding and subtracting is combining like terms. Pretty simple. Okay. Multiplication. So the only thing about multiplication is that you do need to simplify your answer when you're done, and I'll show you what I mean. So let's say I have two terms, 3i, and I'm multiplying that times 6i. So you're going to multiply your coefficients just like you normally would do. 3 times 6, 18. And what would you do if that said an x times an x? Then you would say x squared. So you're going to do I times I, and you're going to say I squared. And that's fine and dandy, except that we already know that we could replace I squared with its equivalent. So if we think back to when we said I equals the square root of negative 1, and then we squared the whole equation, and we got I squared equals, these are inverses and cancel, negative 1. Then anytime I see an I squared in an equation, I can simplify that by putting a negative 1 in its place. And you do want to do that whenever you can, because you need to try to get rid of as many i's in your equation as you possibly can. So I'm going to replace this with negative 1. And so now that basically just says 18 times negative 1, which is going to give me negative 18. And that's going to be my answer. Okay? How about 5i times negative 4i? Again, multiply the coefficients. 5 times negative 4 is negative 20. And I times I gives me I squared. But I have to replace that with negative 1. So negative 20 times negative 1 is now going to give me positive 20. Okay, so it's just a matter of simplifying. And then the last operation, I know there are 4 boxes, but there are really only 3 operations we really have to deal with. The last box you can use to make yourself some mental notes to review before a quiz. This box is all about foiling. So now I have a binomial that has complex numbers in them, or imaginary numbers in them. And so I'm going to have to FOIL. So first, 2 times negative 3 is negative 6. Outside, 2 times 5i, that's double 5i, so 10i. 3i times negative 3 is going to be negative 9i. And 3i times 5i, 3 times 5 is 15, and I times I is I squared. So a couple things we have to do here. Combine like terms. -6, 10 minus 9 is 1. And then the last thing we need to do is make sure to replace our I squared with -1. So 15 times -1 is -15. And then again, combine your like terms. -6, -15 is -21 plus I. A lot of times you'll see this written the other way around. Instead of leading with the negative, we like to lead with the positive, so we would swap this around and say I minus 21. That's primarily how you will have your answer read to you. Typically they switch them around. Okay? So that is operations of imaginary numbers.